Hi there. So what I want to do in this video is I want to go over the exam 2 review questions, and I thought it would be cool to make this into a video. So feel free to fast forward to whatever particular question that you would like to know the answer to. All right, so number one, the Red Cross estimates that 45% of the U.S. population has type O blood, 40% of the U.S. has type A blood, 11% has type B blood, and the rest has type AB blood. Assume that 4 independent donors are randomly selected to give blood. All right, so what's the probability that a single donor has type A or type B blood? Our keyword here is or. So we need to find the probability of type A or type B blood, or AB blood. Okay, we know from our rule on the probability of A or B, we know that this will be the probability of event A, which for us will be type A, plus the probability of type AB blood. And quickly, I will say that because these events are disjoint, meaning a single donor can't be both type A and type B blood, there's another part to this rule that says you subtract away the probability of A and B, right? So the type A and type B blood. Well, since, like I said, these events are disjoint, that probability is 0, so this is the formula that we can use. Now we just simply grab these values from our problem. The probability that somebody has type A blood, let's see, they told us that was 40%. I'm going to write that as a decimal, it's 0.40, plus the probability that somebody has type AB blood, that's going to be, well, we need to figure that out really quickly. So I'm going to come up here. So 45% are type A. Okay, we have, excuse me, that's type O. Okay, we have 40% that are type A. And we have 11% that are type, let's see here, type B. So what is type AB? Well, assuming that these are all the possible blood types that a person can have, 45% plus 40%, that's 85%, plus 11% is 96%. So this adds up, and I know it's really hard to see, guys, this adds up to be 96%, which means what's left over out of 100%? 4%. So we can say that 4% of people, I'm going to come over here to the left, 4% of people have type AB blood. Okay, so that's what we're going to put into our formula for part A. It's going to be 0.40 plus 0.04 for 4%, and we get a grand total of 0.44, or 44% of people will have type A or type AB blood. Okay, what's the probability that all 4 donors have type A blood? Okay, so the probability that all 4 are type A blood. Well, this is what we call the multiplication rule, the case where we need and, because we need the first and the second and the third and the fourth to have type A blood. Well, because they are independent of each other, that means that the probability is going to be the same for each person. So what's the probability that somebody has type A blood? They told us in the problem that type A was 40%. So what we do is we take 40% from the first person, and it gets multiplied, because it's and, by 40% for the second person. Remember, we have 4 donors, so we're going to multiply this value out 4 times. So shorthand notation is that this is that 0.40 raised to the number of donors. In this case, is to the 4th power. And we get, let me go over to my calculator here. See if I can find it. All right. Take 0.40. I'm going to raise that to the 4th power. And I get a 0.0256. So there we go. Let's box these up so you can be clear. All right. Here we go. What's the probability that none of the 4 donors have type B blood? And excuse my not perfect English here, but what's the probability that none of them are type B blood? Well, what's the probability that somebody has type B blood? They told us 11% of the population has type B blood. So if 11% have type B blood, that means subtract that from 100%, and that will tell us the percent of people that do not have type B blood. And that's going to be 89% do not have type B blood. So what we're going to do is we're going to now take that 89%, and since it's, once again, it's another and problem, we're going to raise it to the fourth power, right? Because we need the first person not to have it, we need the second person not to have it, the third, and the fourth. Which gives us 0.89 raised to the fourth power, which gives us let's go 3 decimal places. I'll do a 0.627. So 62.7%, if we were to write that as a percent, is the probability that none of the 4 donors have type B blood. All right, next one. What's the probability out of the 4 donors, at least one person has type A blood? Okay. Well, we're going to invoke something called the complement rule. And the complement rule says, well, the probability of at least one will always be 1 minus the probability of none of them having it. Okay? So the probability of at least one person having type A blood will equal 1 minus the probability of that none of them have type A blood. Well, we're going to do a similar trick to what we did in part C, because they told us, let me see if I can highlight it here, 40% of people have type A blood. So that means that, well, what's the remaining percentage out of 100%? What's the complement of 40%? It's 60%. So there's a 40% chance that somebody has type A blood. It means that there's a 60% chance that they do not have type A blood. So 1 minus the probability of none. So if I want I don't want any of my 4 donors to have type A blood, it's going to be that 60%, 0.60, because I don't need them to have it, raised to the fourth power, because we have 4 donors. Let's see what that gets us. I'm going to do 1 subtract 0.60 raised to the fourth, and that gives us a 0.8704. All right, so there's an 87% chance that at least one of our donors has type A blood. All right, moving along. Number 2. Consider the following probability distribution for a discrete random variable. The table provides the probability distribution for X equals the number of vehicles owned by a Florida resident. What is the expected number of vehicles owned by a Florida resident? Well, it turns out that expected value is the same thing as the mean. And the mean for a discrete probability distribution is the summation of the value of our random variable times its associated probability. So what does that look like for us? We take our first value of X, which is 0, and we multiply that by the probability that we get 0, which is 0.81, or excuse me, 0.081, plus next value of X is 1. 1 gets multiplied by 0.414, because that's the probability of us having 1 car, and so on and so forth. 2 times 0.382, and then lastly plus 3 times 0.123. Okay? So we are going to put these values into our calculator. Okay? So let me clear this out here. So we can type it in exactly how we have it written. So it's going to be 0 times, I believe it was a 0.081, close parentheses, plus 1 times, I believe that was a 0.414, plus 2 times, or let's be correct here, parentheses 2 times, and what was the value for 2? It was 0.382, okay, plus now 3, I did it again. Let's do parentheses 3 times 0.123. That was the probability for 3. We push enter and we get 1.547. Which the question tells us to round this to the nearest integer, which means we're going to round this up to 2. We round up. Remember, if it's 5 or higher, you round up. So 2 would be the answer to this question. All right, moving along. Number 3. The heights of women aged 20 to 29 follow an approximately normal distribution. And so this notation indicates, let me highlight it for you. This first number, when you see n and in parentheses you see the first number is the mean. And then the second number is the standard deviation. Those are very important because when it comes to normal distributions, we always need to specify the mean, which is the center of the normal distribution, and the standard deviation, which tells us the spread of that normal distribution. What percent or probability of women are between 60 to 66 inches tall? So what this question is asking here is, hey, what's the probability that a randomly selected woman is between 60, so X represents a randomly selected woman, her height, and 66 inches. Well, how do we do that? This is StatCrunch. In StatCrunch, we're going to go, let me pull up StatCrunch here. In StatCrunch, we go to the stat column, we go to calculators, and we go to normal calculator. So let me write that down for you. That was stat, calculators, normal calculator. All right, once we're in the normal calculator, okay, we need to know the mean and the standard deviation. Hopefully you can see at the bottom. I know it's a little small here, but at the bottom, oh, I can zoom in. We need the mean and the standard deviation. Well, they told us the mean was 64.2 and the standard deviation was 2.8. So let's put those in. Okay, so our mean was, can I scribble it out? It was 64.2 and our standard deviation was 2.8. Okay. Now we need to understand what type of calculator should we use here. I know we're in the normal calculator, but if you see in this top left option here, you see where it says standard or between? We're going to do the between option because we're going between 60 and 66. So I'm going to select between. All right, there we go. And then we just simply fill in our lower number as being 60, our higher number as being 66. All right, we press compute. And there is our answer, guys. To 3 decimal places, it's a 0.673. Okay? All right. What is the cutoff for the top 10% of women heights? What's the cutoff for the top 10% of women heights? Well, now we're going to go backwards with that calculator. Now we know, so this decimal that we calculated, guys, that is the area, or that's the probability. Well, we know the probability for part B, we just don't know the X value, the height that leads us to that probability. So we have to go back and find that. So to do that, it's a very simple process. So if I want the top 10%, that means I'm looking at area to the right. If it says top 10%, it's area to the right. If they say lower 10%, that's going to be a left area situation. And if they say central area, that's going to be a between situation. But anyways, what I'm going to do is, since it says top 10%, what we do is we go back to our normal calculator. We keep the same mean, the same standard deviation, but this time, since we're only going in one direction, we click the standard option. Okay? And now in that standard option, we need to select, do we want to go to the left or to the right? Top 10% indicates we go to the right. Okay? So now 10%, 0.10, where does that go? Very important, guys. The 10% actually goes in this, if I could scribble it out, in that far right column here, we put the 0.10 here because that's the area to the right. We're trying to figure out what's the x value, what's the height that gives us 10% area to the right. Well, if we click compute, it'll automatically fill it in for us, and we can see the first decimal place is 67.8. And look at the picture, guys. The picture is telling us there's only 10% area that's red, that's shaded. So 67.8 is our answer. Okay, last question. What height has a z-score of 2? So to remind ourselves, the z-score formula is we take our data value minus the mean and divide it by the standard deviation. Well, in this particular question, we know the mean, we know the standard deviation, we even know the z-score. What we're doing is we're solving for that data value, which is the height. So now let me just fill in the values that we know. We know the z-score is a positive 2. Remember, z-scores could be positive or negative, or even 0 for that matter. Equals, I'm just going to call the data value x, that's what we do not know. Minus, we know the mean. Remember from before, we said the mean was 64.2 earlier in the problem, divided by a standard deviation of 2.8. So now let us solve this. This is where we do a little bit of algebra. And let's solve this for x. My first step is to get rid of my denominator of 2.8. I need to multiply both sides of the equation by 2.8. Okay. 2.8 times 2, that is 5.6. Equals, and the reason why we did that is because now our denominators cancel and we're left with x minus 64.2. All that's left for us to do is to add the 64.2 to both sides of our equation. So let's do that now. I'm going to add 64.2 to both sides of this equation, and we should get, let's see, 8, 9, that's 69.8 is equal to x. So that is the height in inches. So a woman that has a height of 69.8 inches has a z-score representative of 2, which means her height is 2 standard deviations above or more than the mean average height for a woman. All right, guys, I hope that helps you understand how to get the answers to the study guide. I look forward to seeing you in another video.